So it's my pleasure to I think last year or this year they launched the best paper popular from 10 years ago, right? So today we'll tell us a bit about some very interesting stuff, how to employ economic approach to correctness.
Thanks very much. So yeah, I think I'm probably in the field of software correctness the least distinguished speaker here, but I'm going to talk about some sort of in-progress ideas that I hope will stimulate some new thought in the area. This is work that I did in collaboration at, or started when I was on sabbatical at Harvard with these people in the economics group there in the computer science department. So when I went to Harvard, I suddenly had to make lots of slides for my very regular lectures, and I couldn't get a screenshot of Keynote, but Keynote kept crashing on me, and it was really driving me crazy. And I was sort of thinking about what should I do on my sabbatical, and so I thought, well, maybe I should work on software correctness since I'm having so much trouble with Keynote. You know, software correctness has kind of fallen into two basic categories of approaches people have tried. One is kind of following an engineering metaphor, which emphasizes methodology and process. And you know, I've always found it extremely unsatisfying. It's not really quantitative, and ultimately you get into these religious discussions about which method to follow and so on and so forth. Then, of course, you have mathematics-based approaches to correctness that center around specifications, proofs, model checking, and with all due deference to the previous speaker, I think suffers from a couple of fatal flaws. First of all, the reliance on a specification. Any really large software system that I've worked on often doesn't even have really a clearly articulable spec, right? If you build something sufficiently large and complicated, you often can't really fully specify it. And then there's also just the problem that they haven't scaled, although in the last couple of decades there has been a lot of progress on this. But coming from IBM research at the time, I'd actually worked with Martin and Iran on correctness proofs of real-time garbage collection, and I was pretty frustrated with that approach, so didn't go on from there. Of course, I can't resist putting up this quote from Edgar Dijkstra in 1972, claiming that by the end of the 70s, software was just going to be virtually free of bugs. So a couple of observations about bugs. So first of all, they have this kind of long tail property, right? So if you took the bugs and sort of sorted them by the value of fixing them, there's this really long distribution, certainly in most large pieces of software that we've used. And you know, if your problem lands over here, then you're generally in good shape because it'll get fixed pretty quick. If your problem lands over here, then you're probably out of luck. And my problem was the interaction of a certain version of Keynote with my certain version of Mac OS, so I was out of luck. Right, so these get fixed, These don't. And interestingly, those ones all the way on the left often are security bugs. And so that actually gave rise to some of the first work in applying market ideas to software correctness, where people came up with this idea of security markets. So you would basically create a market for people to find security bugs. Now, of course, I said the bugs are sorted by value, but, well, how do we sort them? How do we value them? That's not clear. How do we determine the costs? Also not clear. Another, I think, really fundamental problem in software today is that users and developers tend to be very isolated from each other, right? Just because if you've got a successful piece of software, you've got a huge user community, it's very easy to get overwhelmed if you allow all of those users direct access to the developers, right? So, Apple didn't, when the error pop-up came, it didn't say, the author of this software can be reached at, 800-666, etc. So, sort of almost by coincidence at Harvard, I met a group of people there, David Parks, Yiling Chen, and their students, working on applying economic ideas to various aspects of software. And so just started talking to them and thinking about, well, can markets help solve this problem? So we have lots of work, we have lots of workers out there, and we have lots of real value for doing this work. So, imagine if there was an additional button on this error pop-up, and you could offer a bounty, and in the tradition of micropayments, the default value is 99 cents, or you can bid the average or the maximum or some other value. You might or might not choose to give people information about how many other people have bid and how much and so on. So, what this does is it lets you give real feedback to the developers of the software about what you really care about, and you quantify it with dollars, and it lets you help to create a market to attract people to work on the problem that's important to you. So let's sort of try to quantify this a little. So we have a set of users, U. We have a set of jobs, these bugs to fix, J. We've got a set W of workers who might fix the bugs. And then user U offers this reward, RUJ, for job J. So the demand for fixing a particular job is just the sum of all the bids. But now we can sort of say, well, the correctness demand for this piece of software overall is the sum of all those bug bounties, right? Now, the interesting thing there, of course, is that if the demand is very low, that could mean one of two things, right? Either the software is really reliable and almost no one is being affected by bugs, or no one is using the software and no one cares that it has bugs. Now let's talk about supply. So we have the demand from the users, we have supply of workers. So different workers will have a different cost for fixing the bug represented by job J, right? I might be an expert in Firefox, but know nothing about Tomcat or something like that. So the cost to me of doing a particular job is different depending on my expertise and also depending on the economics of where I live and so on and so forth. So different workers have different costs. So for a given job J, there's a potential value that it has over this community of workers. So for a given worker, we take the reward offered for the job and we subtract their cost. That gives you their profit. Obviously, they're not going to do it if it's 0. So we take the max of those. And then over all of the workers in the system. Right? So that gives you the potential, who could get the most profit for fixing this bug? There's some worker there. And then we talk about the correctness potential of this system as just being the sum of those potential values for each of the individual tasks. Okay, so potential is just the sum of those values. And so now, what's correctness? Correctness is just a system in equilibrium between supply and demand. So when this correctness potential reaches 0, we now have a balance between the demand for fixes by the users and the value of doing that work to the workers. Now, of course, in a real system, that's not a static property. The whole, a dynamic, living software system is constantly evolving. People are constantly finding new bugs. Bids change. You have workers entering the system, leaving the system. So the goal that we set out with is to try to design a system where the mechanism design tends to drive towards a dynamic equilibrium where that correctness potential reaches 0. It'll never reach 0 in a dynamic system, but there'll be this constant pressure towards it. So an observation to make in this context is that when you look at it from this economic standpoint, there's no difference at all between a bug and a lack of a feature, right? So if I want a piece of software to read a new file format, it doesn't matter whether when I try to read that file format I get an error pop-up or whether there's no option for me to read that file format. To me, those things are, it's sort of equivalently useless. So you can turn that around and say, well, okay, let's let people bid for features. And the great thing is we don't need to worry about this distinction. We just let the economics address the issue, right? If there's some bug and people really want it fixed, they'll bid on that. If there's a feature that people really want and they're happy to leave this bug in the system, so be it. And you can go even further and say, well, I could consider it a bug that there's no application out there that does what I want. Right? It's sort of a bug in the universe of software. So, we sort of started with this idea, and then we said, well, can we sort of reimagine the whole process of software development? So I want a piece of software created, so I come up with an idea. I'm going to now fund the development of my new idea for software via crowdsourcing. But I'm lazy and I don't want to create a startup and hire programmers and do all that, so I'll just once I've got the crowdsourcing, I'll take that money and try to attract an open market of programmers. And then once the software reaches a certain level of maturity, I want to deploy it to a wide market of users. And then they'll report bugs and missing features. And users will bid for these things to get implemented or fixed. And programmers will jump in and fix the bugs and improve the software. The fixes will get tested, and then the whole thing will continue in this virtuous cycle. Seems a little far-fetched, but in fact, all of these components exist pretty much individually. They're not connected yet. So let's go through. Well, most of you have probably heard of Kickstarter. So this is a crowdfunding outfit that you can go and propose building a piece of software or hardware or anything you want, and so here's this is one I just pulled off last night. So they said, well, we need where was it, $75,000, and they've actually already got $88,000, and they've still got a month to go. Okay, so this isn't really large efforts. Significantly higher than this have been funded this way. Okay, so now we want to implement this with an open market. There's this company called Topcoder that basically tried to attack the supply side of this equation by having programmers, and you could come and with a specification, and then programmers could compete to implement that specification, and then there would be a screening, which would be a series of automated tests in most cases, and then there would be a kind of peer review, and then one person would be selected as the winner, and they would collect the money for that development. So here's a guy in Russia. He's made $35,000, and I really love this. He has an algorithm rating, and they have algorithm competitions. They have design competitions. It's not just specifically for coding. So you have access to all of this quantitative information about how well he's done. So now you want to deploy it to a wide market. Well, now you've got these app stores, and in the case of the Android ecosystem, there's you have this delivery vehicle which is taking care of all of the logistics of software distribution and helps you build a user community and so on. So now you can deploy. You've got systems like GitHub where users can report bugs. Most of you have probably used something like this or Bugzilla or whatever. So here's a bug for canvas zooming. And what was really exciting to me is that this idea that we were working on back when I was at Harvard, there's a startup that got off the ground just a few months ago called Bounty Source, which is doing exactly this. You can go in and offer a bounty, and there's $1,070, And now we have these nice established micropayment systems that are widely accessible. So you can just offer a bounty. And they collect 10% overhead, so better than Apple. And at the top, here's the page on bounty source for this software component, fabric.js. And so here you see these various bugs, and they're sorted by value. And then there are also ones that have been completed down at the bottom. So, and you can see over there on the left, there's, the total value of the ecosystem in that piece of software. Now, as I said, they're only a few months old, so there's only one or two pieces of software in there that have a large amount of money in them, but hopefully this is going to take off. So, so how are we going to go about designing a market that lets software be created and maintained in this completely open, disintermediated way? So the principles that we sort of came up with is, first of all, autonomy. So all of the actions in the system should be market-driven. Now, this is an ideal. We're nowhere near that yet. But fundamentally, what we'd like to do is take out the notion of there being any one blessed person to make decisions, and to have all of it evolve organically through this market. Another one is inclusiveness. So all of the people who are contributing to the development of this piece of software should be rewarded. So, there's value in discovering a bug. There's value in fixing a bug. Another one is transparency. So, people should be aware of what's going on. It should be open so that people have faith in the system. And then, very importantly, reliability. So, lots of these market-driven systems are susceptible to various kinds of manipulation and collusion, and trying to do the mechanism design to prevent that is very challenging, and is a big part of the sort of research challenge of doing this. So the other thing I wanted to mention is that this is an area where we can both bring market pressure to bear, but this isn't an either-or with the development of software tools. And in fact, what we can imagine over time is, if you come up with an automated mechanism to, for instance, do some of the testing tasks, then you could just build a bot which under the covers has your tool and watches for testing tasks, jumps in, performs them, and collects the money. Right? So initially, you'll make lots of money, and then people will notice that, and someone else will jump in and do a tool. And hopefully, that'll create an environment where we create these automated tools that start driving down the cost of that testing or whatever other aspect of the system. So another thing I would like to see is for something like this to drive out inefficiency in the creation of software. So this is just a snapshot of the sort of first screen of what happens when you go into the Apple App Store and search for flashlight. There's literally, I think, about 100 flashlight applications in the Apple App Store. So, that's not really doing anyone a favor. when I go, I have to sit and say, oh my God, which flashlight app am I going to download, or am I going to ask my friends or read the reviews or whatever? And there's been a lot of, maybe you need 3 flashlight apps, but there's been a lot of duplication and wasted effort here. And it would be nice if, by having this kind of marketplace, instead of 100 flashlight apps, we could use that market to bring those people together, and maybe 20 of them would say, let's create the world's greatest flashlight app and band together and do that. So what are the components of this kind of system going to be? So fundamentally, we need ways to fund it. We need a way to sort of tie together this workflow, these kind of discrete pieces I showed you. And then we need some kind of, we also need some kind of reputation system to help act as a regulator on the people who are involved. And reputation systems are a significant way that we can try to deal with these problems of collusion and manipulation. So there's a whole bunch of different models of just what you use for funding. The sort of earliest systems, I think Sun, had for Java, maybe you could vote for bugs to be fixed or something like that. You can also have this kind of fake currency that you can give out. But cash is king, so we're really trying to pursue a model where we can drive real money into the system. So as I showed you, you can have direct user bids. What I've showed you so far kind of emphasizes, I think, open source software and how that would be developed, and certainly Bounty Source explicitly is designed for open source software. But in my role at IBM, I'm also thinking about closed source software. And so in that kind of environment, there's still, I think, an economic model that can be brought to bear here, which is, so we have a customer who spends $100,000 on our software. We can say, okay, well, we're going to allocate to you $5,000 that you can use to bid on bugs and features and so on. And it's not going to be fake money, it's going to be real money, right? We're going to allow our programmers to actually collect that money. So it's also a way to give your programmers a raise. Although I'm sure they'd figure out how to cut people's salaries once they did that. You can also have an escrow model for shareware or even for registration of open source software. So for instance, Mozilla makes the bulk of its money by selling the placement of its search bar to Google. So it's not like, they don't have any money. If we look at the workflow of a bug, right, there's a lot of distinct things that are going on here. Someone's reporting it, people are bidding on it. I think a really important aspect that's going to emerge is categorization, right? So, if I have thousands of or hundreds of thousands of users, how do I know when they're actually bidding on the same bug? Right? So this categorization and saying, oh, these two things are the same bugs, these two things are different, that's actually a hard problem, and it's a very valuable thing to do, right? Because if I aggregate the demand, then I'm providing a really valuable function because I'm, instead of leaving lots of $5 bids on the table, I maybe create a $10,000 bid. There's reproducing the big bug, fixing it, testing it, committing it, distributing it. So, so how do we create this ecosystem where all of these people can participate and share in the reward? And of course, how do we decide who gets how much, right? That's going to be a big part of this equation. And, of course, the testers will complain that they're not getting enough. So, how do we decide whether two bugs are the same? We could look at the line number of the crash. We could look at the data that was the input. And it's also very hard to decide, when, so someone submits what they call a fix, but really all we know is that it's a change. It's certainly possible, well, maliciously someone could say, well, I have a fix, and they've really sort of masked it and circumvented the tests. And of course, we've all had that experience that you fix one bug and, only to expose or magnify another one. And finally, there's this issue of quality, right? How do we try to select out between people who've done the kind of Band-Aid patch and the person who's gone in and done the harder work of doing the more structural fix to the software? So one of the things we've been thinking about is whether we could use the demand trajectory of a bug over time to figure out how to apportion the value. So shown here sort of hypothetical trajectories of 4 different bugs. 2 of them are high priority. One is easy to fix, one is hard. So this one here is high priority, so it spikes in value fast, but gets fixed quickly. And so here, so the y-axis is showing the bids minus the payouts, right? So there's a quick fix. We can pay the money out quickly. On the other hand, we have a high priority bug that's hard to fix. The bids will raise, but we won't be able to pay out any money because no one's done anything about it. And then finally, someone will fix it, and then we can start paying it out. In these 2 scenarios, so the first scenario, the blue line, might correspond to a security vulnerability, right? So I discover that there's some exploit. I report the bug. Very rapidly, lots of companies say, "Oh, I'll pay $1,000 to have that patched, so that my whole corporate network doesn't get infected." So in that case, with a very quickly rising demand trajectory, you could say, well, the reporter of the bug provided a lot of value, right? Because he reported the bug and then instantly lots of people started bidding. So you could use that to sort of say, well, okay, in that case, the reporter should be getting more of the value. On the other hand, for this one, where it took a lot more time to do the work, it seems clear that the fixer ought to be collecting more of the value. So, we haven't really figured out how to do this. One of the things we're really interested in now that this startup is out there that's actually doing this is whether we can engage with them and possibly run some experiments of looking at different reward models for different subsets of the software and compare them. So, you know, I mentioned some of these problems already. You know, one of the big issues in mechanism design is avoiding freeloading. So, you know, I look and you know, I get a bug pop up, but it says, well, people have already pledged $80,000 for this bug. I'll say, ah, well, you know, $80,000, that's enough. I don't need to add any money. So I'm sort of freeloading on the system. So actually begs the question of, well, maybe you shouldn't report how much money has been bid, or maybe you should fuzz the report, or all sorts of interesting game theoretic things you can do there. You know, and another big issue, and that gets to the velocity of payout, is you know, sometimes you don't know whether a fix was really a fix until it's been in there for a while. So how do we feed that into this whole reward equation? Okay. And then for a reputation system, right, we can feed this in as well, having ratings based on past performance, and right, people with higher ratings, maybe we can allow them to directly commit software without intermediaries. People who are new to the system won't be able to directly commit until they build up some reputation. So a reputation system can kind of help us organically drive the locus of control of the system without having to intervene manually. So just to summarize, I really believe that this kind of market-based approach is the only scalable solution for software development. And I think it's a really exciting time. We're seeing all of these different pieces of this emerge organically, and hopefully over time this will tend towards the creation of the kind of unified market that I was talking about. So, thank you very much.
And people would be answering when I pay for software, and it's some sort of expectation. And a very different expectation for the feature that was not advertised. And you're right, if I advertise a feature and it's not there, then this is a bug. But this is very different than a feature that was not advertised. Okay, as a customer, I have very different expectations. It was advertised when I pay for the software. You advertise a flashlight. And one thing it doesn't do, it does not create light. I'm not willing to pay for the bug, right? I want my money back. The bigger question is that I'm used to some world organization with 400,000 employees and about $100 billion revenue, that you're coming to work to give this proposal. Because if you go to Jimmy, you see, oh, and here is this proposal, and this one IBM, let's give 400,000 employees, let's make them all free agents. Now, if Jimmy doesn't know you out of your office, what you will do, you will reach out to the bookshelf and will give you a book by Ronald Coase, who just passed away recently, The Theory of the Firm. Which explains why do we have large companies? Why don't we let the market handle everything with free contractors and customers? And that's what the transaction cost, which we completely ignore.
Well, we'll see. I think the you know, the emergence of things like Wikipedia and this vibrant open source community that we have 10, 15 years ago, people would have said that was impossible, it doesn't work. You know, to me, it's still a miracle every time I go to Wikipedia and I read an article and it's actually of high quality, right? So, you know, on the one hand, I see your points. On the other hand, I think things are changing in surprising ways. So, and luckily, I work at a research lab, so I can say these absurd things and Ginny won't fire me.
Let me make a short comment about the Bach feature relation and the previous talk. It looks like Bach is an indicator of program in the past, and then the feature is an indicator of the program in the future.
I wish I had thought of that. Thank you.
Question to you. It looks like in this model, the software with the zero sum of bits is bug-free. Do you think it would be easy to
Sorry, the zero sum of
bits?
bids.
It's virtually bug-free. This idea, would it be easy to sell it to both business and academia?
In what sense?
Well, I guess it would be relatively easy to persuade business people that if we do not have any market requests with our box that can be formalized in terms of cash and bits, we don't have any box in our software, so we don't need to care.
Well, right. I mean, it's you know, this notion of correctness, right? It's if no one's using it, then it's sort of vacuously correct, right? So, but that doesn't mean that it's correct, but it's not useful.
Why doesn't it mean? Maybe it's exactly mean that.
Well,
there is really no feedback that you can issue by. There are no bugs.
well, so maybe what you're saying is there's a null hypothesis. If I have a piece of software that does nothing, then it has no bugs and no one can submit a bug report. But also no one will use it because it does nothing.
If you take economic definition, and take, for example, Microsoft released a Windows software, right? They do an economic calculation, right? So it costs them money to continue to save files. And they have to think about the reaction. They make an economic calculation, and in fact, from their point of view, when the economic value of fixing the bug goes to zero, that's when they release the software. So according to your definition, tautologically, every software that Microsoft releases is correct. It's correct because they made economic decision to release.
No, but they
Well, there's a delay.
There's a delay. If you fix the bug, you're taking a delay in the time to release the software. That's very possible.
But the point is it's economic decision. They make an economic decision when to release. And because they release it when the economic value of fixing bugs has gone to zero, that's when they release software. According to this economic definition, the software is correct when they release.
no, so
No,
because they have no direct feedback. They're guessing. They have no direct feedback from the user.
That's actually not true. First of all, what he was describing was not, what he was describing as far as cost was not taking into account time. But second of all, the big difference between bugs and features is that bugs you actually can tell how much they're costing because you can tell automatically how often they're being hit in the field by automatic bug reporting. So you don't. So that's why the mechanisms for the economic mechanisms for deciding when to have a feature and when to fix a bug are very, very different.
Well, so I agree that they're different from the point of view of Microsoft, but
That's why
I don't
it
agree
makes
that
sense to
they're.
treat them.
Yeah. So I mean, I'm not saying that they're completely equivalent, but from my point of view as a user, there may not be that much difference, right? And the feedback that a company gets when they say, "Oh, okay, the customer had, I've had 500 hits on this bug." That still doesn't tell them what the economic value to me of fixing that bug
Right,
is.
you don't have as a user, you don't have the information to know how much that bug's going to hurt you because of the small sample problem.
Maybe not.
So it just happens it's very different. But the big problem ultimately with this is freeloading. This was actually looked at decades ago, primarily as a way of getting rid of the problem of intellectual property for software. And the problem is that with freeloading, not only does no mechanism is provably efficient, almost everything you think of is provably inefficient. And I've heard of nothing that suggests there's any solution to it that works.
Okay, let's ask some more questions. So we have a question there.
So I'm wondering what you think for what kind of software this is going to work. I mean, here it's not going to work for all kinds of software. Like if there's intellectual property somehow in the software, you can't make it open source, or it's safety critical, you can't have the users report bugs because they're different. Something. So what except flashlights and app stores could be built there?
So I think this is applicable to a lot of actually large open source things, Apache, MySQL. There's a lot of open source software that a lot of, in some cases, large companies are built on, right? Where there's a feedback process where they try to influence what's going on, right? I mean, at IBM, we have a whole team of people who work on Linux and whose job it is to fix things that are of importance to IBM and feed those fixes back into that community, right? So IBM is already paying to participate in this open source community.
Could you characterize the kind of software where that works? Anything that is open source right now?
Well, I don't, I guess I don't know how to answer your question because it doesn't seem, I use the example of the App Store as a way of doing rapid deployment. But if it works for the, Linux, right? I think if it can work for large pieces of software like that, I don't see any, yeah, maybe there are some niches where it doesn't apply, but I would say it potentially applies very widely.
Okay, one more.
Thank you very much for the talk. I'm not an economist, so this might.
Sorry, can you speak
I'm sorry.
up?
Thank you for the talk. I'm not an economist, so I apologize for my questions are not sincere.
I'm not an economist either.
So it seems to me that there is a sort of almost a perverse incentive here for programmers to leave bugs. In a sense, they know they will fix them for a certain amount. And this was sort of the case when I think in some companies they used to say, in the first week, whatever bug you find, it's sort of going to be $10 you get, and then 50 and so on. But I was wondering if it's reversed, so to say, instead of the company giving 5,000, as you mentioned, that sort of a free lunch, but rather instead they actually incur the cost. So they say, if you find bugs for us, then we will lose money because we will give you free software later, or we'll give you free updates, or we will give you cash. I was wondering whether this reversal would make a difference, or have you looked into it, or your comments on it? Thank you.
Thanks. Yeah, so there's, no, we haven't looked into that, but yeah, there's many things you can try to do to address these issues, to create sort of virtuous feedback. But, I think the key thing, and that a lot of, I think the key thing is that we need to integrate in what's going on here the fact that even in these economic systems, you can't leave out the element of community. And I think that's why things like Wikipedia and open source projects, where you kind of look at it externally, and 10, 15, 20 years ago, people looked at this stuff and said, well, this is crazy. This is never going to scale. This is never going to take off, right? But somehow there's a community aspect that acts as a real significant influence. But of course, that is very hard to quantify. But nevertheless, it's there and it's important.
Okay, so let's take a break now. So we'll resume in 15 minutes. There is coffee and